Welcome back to Stats 1, Lecture 9. This is Bill Foote, and we're still talking about the elastic Gauss, where elasticity is brought in order to create a revenue simulation. We pose the question, what is revenue going to be in the very next quarter? We have 4 quarters of data, 4 quarters on a rolling basis, 6 products, 4 regions, and the ultimate matrix organization. Now, we're only looking at revenue. We're not looking at profit. And in fact, we spent a little bit of time in the very beginning understanding a basic driver model of value in the company. The value, and this is a very financially oriented value driver model. There are other very important ones, especially ones that emphasize the management side, where managers then look at assets, operations, and revenue from the point of view of various stakeholders. If we're looking at one of those stakeholders, customers, we certainly have new and existing customers, and they're probably pretty worried about how much they will be able to fit within their economic budgets. Not just what they prefer, but what they need. And we came up with a very simple model of supply and demand, in this case, just the demand side. We're not even looking at equilibrium prices and quantities, which could be pretty complicated, but an incredibly simplistic model of if we have average prices and units sold in a region, in a quarter, by product, we can build a scatter plot of this and run a line through it to get an idea of the trend. It's deviations from the trend that will really excite us, in the sense, if you can call this exciting, in the sense of seeing how behavior actually evolves and how it can be different from the regression to the mean, the mediocre. A common model is this p equals a cubed raised to the b power, which when in logarithmic terms produces this, where b, the coefficient here, is really the ratio of 2 percentage changes. That's an elasticity. We went on from that into part 2, rather abruptly, I might add, to a notion of relationship, which is part of the counting part of what we're doing. Just as taking averages or standard deviations, we can relate 2 different series of data, such as price and quantity, by looking again at their deviation from their means, and then multiplying those deviations together to get a number when scaled by the number of observations, in this case simply 3, we get a covariance. Covariance is not a very useful number for us. Very hard for human beings to understand what a price laptop is, if the number of units are laptops, for example. A little bit better one is, again, a scaling, and this is almost a normalization in a sense. Normalization usually means going from 0 to 1. We're also allowing it to go from -1 to +1 because covariance can be negative, as it was in an example. And the usual way of doing this is taking covariance and dividing it by the product of the 2 variants, 2 standard deviations. That is called correlation. And it can range from negative to positive. Strong negative is a -1, and the strong positive is a +1. And relatively unrelated, uncorrelated. And we're not talking about causality here, not at all. Just association. Okay. We went on from there to look at a simple model. It's all in part 2 now, where we just used Excel. And part of the story here was to say, okay, suppose I have 3 prices and 3 pairs of prices and units sold. Can I relate the 2? And we built a little model, and we could do this by paper and pencil, but it's useful here because we could also test Excel's notion of functions, where we take the deviations and find their products. Some are positive, some are negative, and we get a huge number here, divide it by 3, okay, divide it by 3, and that is the covariance. We can develop variances as sums of squared deviations, also divided by 3, to get a variance, and take the square root of that to get the standard deviation, in this case of price, and in this case of quantity. And these all tie up very well with the Excel versions of this. And Excel also has a correlation function that we will use in a couple of minutes. And the correlation function produces exactly the same number as covariance that we produced here, by hand, if you will, divided by the product of the two variances. And notice that you had to put that product in, put it here so you can see it, in parentheses. So that's a review of what we did in part 2. And in part 3, we will have our prices. And I just need to pull that particular one up to show you, but this is what we did in part in another one. And that's my cat saying hello. Let me go take care of him and I'll be right back. And here's the version of the model with price. We have pairs of counts, units sold, pairs of prices, and you can use your imagination as to what's being sold here. For example, at Best Buy, $1,300 for something. First thing we do, of course, is create from selection, top. We now have price. With this, you can see down here, there it is. We have that new array so designated. There's a number of things we can do with this, but the first thing we're going to do is we're going to go to control, just see what we have here so far. We have these parameters, x bar, SD bar, and max mu. And they come directly from our simulation in the analysis sheet, just way over here. Okay, and we're going to make some modifications here. We had shown pretty conclusively that the most likely means of all of these, 10,000, is equal to simply the average of the means. That's what we showed. Pretty cool. 10,000 of these, we computed 10,000 of these means. Here they are over here. And we did that in the other lecture. All of these. Okay. Well, right now, what we have here is the north quarters, 6 different products, and this is a regional report, Northeast, Southwest. And these are units sold. So the first thing we need to do is make a revenue report out of this. And that's pretty simple to do. If we simply take this sum ifs, copy it, and paste it over here. But before you do that, put an asterisk for time, because it'll be price times quantity. There we go. As it stands right now, it's just, that's just quantity squared. If we change this first count, can you see that? Change this first count to price, like that. We now have revenue, $3 million worth of revenue. And if we shift right arrow, up arrow, Control V, we now have a revenue report. So we can call this sample revenue. And the sample revenue, as you can see, is again index. It uses the thing called the sales table. I'm going to fix this so it looks a little bit easier to read. This is actually a revenue table. Formulas, define name. TBL. Okay. And this index will index the revenue table. See, it's indexing that highlighted area. Okay. TBL. We're still using RAM between 1 to 6, which is for the products 1 through 6. And in the columns 1 through 4, which is quarters 1 through 4. Press enter. And just swing this across the 4 quarters, and we get a sample revenue. Okay. So that's pretty good in and of itself. But if we want to do a revenue simulation, which of course we want to do, we need to do something with that column. Oh, that doesn't look right. Yeah, those are all in thousands. Okay, what we need to do is take the revenue. Here's the highest revenue we're going to simulate with our grid and make it 1,000. Use the 0. There we go. Make it millions. Now it's going to look like lecture 8. And in millions. And now it's not millions of units. It's US dollars millions. And that documents that very nicely. That should be $110,000 worth, okay? And we just expand O here so that the human being can see it. There we go. 11 and 11, we have 22 different scenarios, which are pairs of mu's and sigmas. We'll keep the same mu and sigma, which is $1 million or $1.5 million of movement in revenue, not a small amount. Okay, so we have that, and over here should almost all work. But we have a division by 0. Why? Because all of these are of 0 probability. If mu is that small and you have a revenue that high, it's going to be of 0 probability. So we have to divide these also by the same scale as the grid. Little lesson there in making sure everything is aligned. All the stars must be aligned together. And now it all appears. Everything that we have worked for appears. How nice is that? Okay. And actually, we can simulate this right now and get a revenue, an idea of a revenue forecast. And if we click to simulate, it'll take a couple of seconds here. And notice that it's simulating off of 10,000 recalculations here and here, and just depositing them all here. We should see this change. Not a small simulation. It's a lot of calculation going on. So we give it a, as long as that wheel's going around, that's pretty good. And congratulations, 10,000 simulations over. Okay. Okay. See it changed. And we created a tabular structure to examine the probabilities, basically, beginning and end, and so on. Of what? AQ, the max, that's the min of the grid. Okay. So the mu's, we're looking at all the different possible mu's. And we created a grid over here. Let's encase that in stone. Yeah, put a nice wireframe around it. Now it's a little bit easier for humans to see again. over here on the left, if we're doing max mu in this particular case, notice we have max mu 10,000 of those, standard deviation of our samples, and the mean of our samples, X bar. Okay, we're doing that. We could do this too, but just watch this. The IQR 1.39 would be very revealing. Okay, now we have X bar. Now, X bar 1.39. All of the X's, live in Texas, of course. All of the X's were done like this. And we needed to also divide by 1 million here. And this standard deviation, which is the correct units. These are all in revenue units. And I think that's correct. And let's do this again. And now everything will be scaled in millions and consistent across the entire analysis. So we wait for the magic wheel to spin around, give us the answer. The answer is 42. Just about now. Not enough time to go and get a cup of coffee? Well, that's too bad. And you can see everything is hunky-dory over here. Yeah, about 1.4 is going to be the IQR. 50 percentile is 2.3. The mean is also about 2.3. This is for the simulation. If we look at mu, these are the most probable means collected every single time from our probability grid, our plausibility grid of 22 scenarios. We see, again, almost 2.3 here at 50. Yeah, the mean is still about that. And they're all consistent with one another. Okay, in the entire thing. We have built a revenue report. How good was that? Now we can also put in price and quantity into this revenue report. And to do that, we need to copy this table this whole table, Control C, copy it down here so we don't have to rewrite this whole thing. Put it down to 17 here. And it should all come up 0. And the reason is it can't find anything in our database. Why? Because this doesn't refer to the correct things at all. It should refer to Lancaster. And there's a way to automate this so that we don't have to do this each time. And the other thing is, well, we don't need prices here. We only need quantities. So let me get rid of this. Press enter. Those are sales. And we do this all the way down. And now we have a sales report. Okay, now one thing I want to get rid of is this, and let's do that in the next round. Okay. Let's try this again. Let me fix something there, and I think I did. Take a copy of that, put it down in 17. Remember, that should be on that all the way down here. There we go. Pretty straightforward. And because we want a sales or units sold report here, Notice this really doesn't matter anymore. Get rid of it. Because it's the same thing. If you change this, nothing happens because it's always these numbers and these numbers are always going to refer to region choice. And that was one of the reasons why we needed to do that in the background, just so you know. Now, all we need to do here again is take out this price. So just to repeat, get rid of that mark, which I did. And there we go. Now we have units sold. And that's a wrap there. Now we can just take this report and now we can make a price report out of this very quickly. Let's call this price. These are the average prices by, well, let's first of all fix this. Okay. And you notice I'm hacking away here. Can I make it cleaner, more elegant? Absolutely can, but we're not going to bother with that at the moment. We're going to show how to use this model. Instead of count, we need price here. Capital P-R-I-C. If you did not make that a named range, this will not work. And there we go. Now we have our price report. Now, more importantly, we have a revenue sampler up here, a table. We're going to need to have a sales table. We should take care of the old sales table pretty well. If we go to formulas, define name, call this sales, TBL. It's going to hiccup a little bit. Watch it, because we'd already defined this. Say yes. That's the new sales table. Okay, that's the new sales table. If we go here and we pull up sales table, check it. Nope, that's the old sales table. So we need to change that, and the way to do that actually is in Sales Manager. Now you can either get rid of it. I don't know, like quarter one is there. Oh, I see what had happened. Yeah, I tried to make it quarter one. Can get rid of that, definitely. Okay, see, okay. So we don't need that, that's meaningless. Here it is, sales table. And instead of this range, do equals new range here. There we go. That array will do it. Okay. You want to change it? You certainly do. If it works. And it does. So that's good. Now we have a sales table. If we have a sales table, we can do a sample underscore sales. Use this formula again here. And instead of revenue, type in sales. How clever is this? Not very, but effective. And now we can sample sales. Now we're not going to sample pairs of sales and prices that are absolutely paired together. We could do that. But I think it's an actually better design to mix it up, to show all the possible 10,000 different ways of doing this. And if you were to take the 24 items on the table, 4 at a time, you're going to get over 10,000 different combinations. So 10,000 is a good number to use. We might use 100,000 to be safer. So we also want a sample price. Getting that prepped up for us. Go. And the price will have also a price table. It's good for documentation, but also for following. This is WYSIWYG. It's all over the place. Following the logic of what you're trying to do. It's a little bit easier to do when you do it this way with Ingracious. Find name, call it PRICE_TPL. Check that that's in there. In this increasingly long list. There we go. That's the price table. So instead of sales here, price, index the price table. And there we go. So now we have sample revenue, sample sales, sample price. Now we've already used the sample revenue over here. Let's call it what it is. It's a little easier to use instead of that old thing, sample revenue. Okay. And we haven't called it sample revenue yet, so let's do that. And if we select this whole region and create from selection, it will know to use the left column, and we will agree with what it thinks it knows by saying okay. And this will be called sample revenue. See, it's coming right up. And we'll make this sample revenue. So we've actually improved on our etiquette here, a little bit of our spreadsheet hygiene. And we've got that as well. Okay, so far, so good. Pretty much everything else is going to work out fine. Got this set up. Here are our, yep, it's going directly from the sample revenue. We have these. We're gonna redefine these just a tad differently here. We're gonna take this and move it over a little bit because we also want to put in price and quantity. Okay, we're gonna call this P bar and Q bar. You can be much more creative than that. And center those. That'll be the bar. Remember, when we put an overbar on an overline or a bar over a variable, it typically means sample. And these are definitely sampled. We're closing our eyes and just going into the 24 bin box and just pulling out a price for them. Okay, pricing. Put the price back in. Take it. Go in and take another one out. Okay, it's done with replacement. Same with Q. And this is going to be equal to the average of price sample like price sample. So let's see what we got over here. Oh, sample price. My dyslexia comes back again, rearing its ugly head. Okay. It's not so ugly. Really inconvenient, but it forces me to be careful. There we go. Sample price. There we go. That looks reasonable. Okay, and this will be sample sales. Now, sample price, we're going to keep at 618. And sample sales, we're going to keep at this. Even though revenue is going to be expressed in millions, these are going to be expressed in the absolute dimensions of US dollars. Is that everybody all right? We can put that down here. US dollars per minute. And that's in units. Okay, units sold. This one here is in millions. So we'll do times one. Oops. That's dollars. Okay. And all three of those are actually that way. So I just merge that up. And put a wireframe around that. And now we know what we're doing. We are going to put in one more item, and that is the correlation between price and quantity. So we're just going to call this core underscore P underscore Q. And we'll just pop that right here. And that will be equal to CORREL, the samples. So we have sample price. We have sample sales. And I think I needed 2 R's. Yes, I did. I was thinking of an old product sold by Corning. Oh, very low. That's an interesting idea. Wondering how that will work. Ha ha. Try again. Ah, very negative. See, it's going to be quite a few different ones here. Oh, we're going to get all sorts of different numbers. That's wonderful. We want that. Okay. We're almost done with the segment. Now, obviously, we have to expand our horizons over here. And one way to do that rather easily, over here, you see, over here. Okay. We have X bar, SD, max mu. Okay, we have all of those. One way to do it without changing too many things is to put your cursor there and highlight, in this case, column AK. And we're going to insert some columns. A couple more columns. So at least these two will get inserted, and we're going to insert one more for the correlation. Now, what's going to happen here is we will put equals P bar. We can arrange these any which way we want. And this 812 will appear. It'll be a new one now. So every time you do this, calculation is automatic, and we want it that way. We're going to tell our Visual Basic script, when we automate this, to reset that as we go forward, so that we can manually, that is within the script, do a calculation of specific pieces of the spreadsheet. Now that's all cool. This one here will be Q bar. And I must have hit something wrong. Okay. Go. Copy this over. Good. And finally, we're going to get the correlation. Steps away from completing our assignment. Right at the threshold of a dream. Okay. Now, if I ask the question, where is the interface? See, because I expanded it within the existing named range, expanded the number of columns, interface now is also automatically expanded. That's what I was trying to point out. And those will come up there. But not only that, look what else happens. Simulation. Also was expanded. Not only that, control will also eventually have AI to AN valve, because it doesn't go all the way down here. That's why. We really needed to expand that as well. So why don't we do that? And these are our parameters. And let's see how this will work. There we go. Now we have everybody. We had to put my cursor back up here like this to release and therefore be able to edit. And now that it's there, just Shift Control Enter, get it. Now, parameter needs to be redefined to include all of these. And there's a technique, and you can research it, and we will eventually use it, where if we have a dynamically changing, in this case, it was dynamic because we added new parameters. And by the way, that blue wheel is going to go around a little bit longer. You can use something called offset to create a increasing, decreasing named range. Okay, and that's been in the books for a long time, and it's a little known technique. I haven't seen it written up hardly at all. We should probably write it up and get it out there. But you can look for it on the World Wide Web. Okay. Replace, you betcha. Okay, let's just check that parameters are there. We're going to need parameters eventually. Now we have all of those. See what transpose does for us. It does help us. Get the right thing over here. Okay, now that's that. And now we should see all of this fill in eventually. So let's hope. Now, where do we need parameters? We do need parameters over here. And if we put in P bar, you see nothing would occur. Okay. Now, the reason why nothing occurs is we have not defined these yet. We will define those in a moment, after we get some numbers in there. Click to simulate. Watch the wheels go around. almost enough time to do a Google search. What search would we do? How to dynamically change a named range with offset. Oh, there, that might be it. I don't think we're going to have that much time, though. And you can see it's doing another 30,000 calculations here. There we go. Say OK. And now let's make sure that we define these as named ranges. Job will be almost complete. Top row. Oh my goodness, it worked. Look at correlation, though. That's the one I want to see. How is that distributed? Ooh, it didn't like that one bit. Didn't like that one bit. Okay. Let's make sure that this is done again. It still doesn't like that one bit, which is quite surprising to me, because we are doing the minimum of the indirect of AQ4, which is this. And we should be able to find the minimum. As a matter of fact, let's just try that. Right now, we're troubleshooting, aren't we? And it comes up with division of 0. Now, why might that be? So let's look through this. We must have had some illegal numbers in here somewhere. Matter of fact, one way to do this is very simple. Go to data. Filter. Look at what's in here. It's looking at all 10,000. There we go. Ah, we've got one that is a division by 0. Why is that? Unselect these. There we go. And just select the division by 0 one. Needle in a haystack for sure. And we have a lot of them in which the correlation was undefined. Now, why might it have been undefined? Any thoughts? How can you get a correlation that's undefined? Well, you can if either the standard deviation is or the standard deviation, one of the two standard deviations was not defined, was a 0 for whatever reason. Now, if that were to happen, a standard deviation of 0, all we have to do is make the correlation slightly positive, the minimum of a slightly positive or slightly negative standard deviation. Okay, that's all we need to do in order to make this work. So that's called jittering. And remember, it's simulation, so there's not that many out of 10,000, but there's enough. Okay, so here's the correlation. So we have to an error type of if statement. If this number, if okay, we can actually use I'm just remembering, we can actually use an error formula to handle this. And let's see what that would look like. So we've run this, and what we've done this time, because of the potential existence of 0 in the denominator of the correlation calculation, remember the denominator had standard deviation of price times the standard deviation of quantity, here sales, units of units sold. We have a way to handle this. We can do this in any number of ways, but the idea is to make, if there is any kind of error in the calculation of this function, set it to, in this case, a pretty high number, 0.01. We could set this to 0.001 to get a little bit finer. In fact, you're going to see some very anomalous behavior in the simulation of quarterly price and sales across the 6 products for the north area, for the north region. You're going to get you probably get a lot better for all of them, but the north region is not so good. We're going to see a wide variation here. But anyways, here's our simulation. And your simulation should take a while, and it may even shut down your system because there's a lot of calculation going on. So you got to be careful. Save your work so that you have it. Okay, this is not a small spreadsheet anymore. We're pushing Excel against some limits. Please realize that we are pushing it against some limits. And one of the limits is this max mu. We're forcing it to recalculate all of these cells over here to the left. And if we eliminate that, a little ease the load. We're also doing a study of X bar, which in our case is revenue, standard deviation, price, quantity, correlation, most likely. So we have a lot of different pieces here to deal with. When I post the correlation, which is from the parameters, okay, see it goes from practically a -1 to a +1. This is what we get. We get almost equally likely correlations 10,000 times over. Okay, this is nearly the definition of what is called the uniform distribution. They're equally likely. And because they're equally likely, here we go. Here's the equally likely part. How equally likely that is. Yeah, 4.5%. Okay, good. Out of all of the 11, you have 11 here. Equally likely. All right, so and that'll give you a for uniform distribution, you get, practically speaking, see what this is? You get, practically speaking, an upward sloping straight line for the cumulative distribution. Okay, and we saw that actually. We saw that actually in week 1 when we were looking at a totally uninformative view of whether or not we would get land or sea. and you get an upward sloping or a downward sloping, depending, cumulative distribution. So where are we here? Well, one last thing, just look at sales. Okay, here's sales, roughly normally distributed. We can see that because the Gaussian and the simulation line up on the cumulative distribution function. Okay, we can put a chart title here. And the chart title ought to put in the name way over here. Oh my gosh. Oh, the report, oh, this is West. Okay. Strap that together. North. Or in this case, West region. Put a colon, space, finish off that string, and put that together with this S bar, which is totally uninformative. The thing is, we can put in something much more informative here and correct the indirect statement underneath this to say if it's standard, if it's sales, average sales, if that's what appears here, then go to S_bar, pick up that range. Okay, you can do things like that. Okay, we will leave that for the more imaginative folks among us. And if we were to go up here to the chart title, select it, go up to the formula, do equals, and come down here, we would see that we would at least be able to have something a little bit more informative in there. Okay, so we change West region to North region, we get something different. Now, if we were to change the region, guess what we have to do? We would have to resimulate everything all over again because all the assumptions have changed again. Okay, and then all the rest would follow. So we're building an app. We have an awful lot of stuff in this app. And what we might clear out are some of the things because we're just playing with it, doing a couple of different studies inside of this, all around all that sales data. Still haven't come to a conclusion yet, but probably the most likely revenue for, in this case, the West region, that's X bar here, will have a range between 1.74 million and 3.34 million dollars in sales. The average is 248. We have an IQR. We have fences. So 0 is not an option, okay, at the bottom. And anything above 5.74 is superior, if you were ever to get that. Okay, that's what the Tukey fence says. The 5 and 95 says anything above 3.34 is wonderful, okay, in terms of sales. And here's the distribution to show some of that. Okay, if you're up here, like that, oh, the maximum is 4.31 in the simulation. You resimulate it, it'll grow and shrink somewhat. And that's an interesting statistic to look at, that kind of behavior of your simulation. We now have a revenue forecast. Imagine that. So I think I'm going to show my face here. There we go. Leave you with this. And again, save your work. Control S. Watch that wheel go around. It's going around a lot because we're saving a lot of data. Save it frequently. It may crash because we're doing a lot of calculations. If it does, usually it restarts. If it doesn't, you're okay. Go back and take your most recently saved, which is just half a minute ago, and bring it in, okay? And you can also set your autosave to every 5 minutes, which is very, very helpful. With that, I'm going to leave you. Hope you enjoyed this lovely session, part 3 of lecture 9 and stats 1. And this is Bill Foote signing off. There will be another small part just to maybe clean up and see a couple of more things here, or maybe not. Check the playlist. Take care and thanks.